This is the brief on why water shouldn't be able to freeze solid inside a sealed container, and the fascinating physics that makes it possible anyway. We all know ice expands when it freezes. It's why jars crack in the freezer. But here's the twist. High pressure can actually melt ice. So that creates a paradox, right? If you try to freeze water in a strong, fixed-volume box, the expanding ice creates pressure, which should stop the rest of the water from freezing. So, how does it ever fully solidify? First, the process is self-limiting. As a little ice forms and expands, the pressure builds up immediately. This new pressure is high enough to prevent any more water from freezing at that specific temperature. It hits an instant equilibrium. Second, the system doesn't just turn solid. Instead, as you cool it further, a little more water freezes, which raises the pressure to a new, higher equilibrium point. So you get this stable, slushy mix of ice and water. The colder it gets, the more ice and the higher the pressure. Finally, the container can freeze completely solid thanks to a special kind of ice called Ice 3. Now this is the key. Unlike normal ice, Ice 3 actually gets denser and shrinks when it freezes. This contraction creates just enough space for the whole thing to finally lock up into a solid mixture of normal ice and Ice 3. So the apparent paradox is resolved not by magic, but by water's complex phase diagram, where everything depends on that delicate balance of temperature and pressure.